Here we're going to look at solving systems of equations using substitution. So we're given the system y equals 6x plus 7 and 3x minus 8y equals 4. But let's just go back for a minute and pretend, let's say we still had this 3x minus 8y equals 4. And let's use a concept that we're familiar with, and then we'll build on it. So if I just said that y was equal to 6, what you would do, right, we would take that y equals 6, and you could substitute 6 for y. So you do something like 3x minus 8 times 6, and then you would set that equal to 4, and then you would solve for x. We're familiar with that, no issues. Now instead of 6, let's say you change that to 6x. We do the same thing, right? We would just change this to a 6x. So we're still substituting, but now we're using that variable mixed in there. So don't make it more complicated just because that the term is a little more involved. And then finally, if I was to change that 6x to plus 7, well, we're still going to take that entire term and substitute. So take the simplified version, something you're familiar with. In this case, y equals 6. And then if we were to substitute that in there, we know what to do with that. And let's just expand on that. So let's get rid of this. And what we're going to look at is here, y is equal to 6x plus 7. So anywhere there's a y, we're going to substitute. So I'm going to take 3x minus 8 times 6x plus 7 and set that equal to 4. So this here is being substituted. And now we have an equation with only the variable x. We can solve that. Our first step would be to distribute. So we're going to do 3x minus 48x. It's a nice easy number to start. And 8 times 7 would be negative 56, and that would be equal to 4. So we want to look at combining like terms. So we're going to combine the 3 and the 48. So if we combine these two here, we get negative 45x. And then we are going to bring down the minus 56 and set that equal to 4. Then add 56 to each side. Get negative 45x is equal to 60. And then finally we would divide by negative 45. And x would be equal to, now you will wind up with a decimal here. So we're just going to reduce that, keep it in fraction form, and if we were to reduce that to a fraction, we would have negative 4/3. And that would be our x value. Sorry about that. Now that we know what x is, I'm going to highlight that in green. So we know x value. We now need to back substitute that x value into one of our original equations. In this case, I'll use 6x plus 7. And I'm going to take the x and substitute in so that I can solve for y. So y is equal to 6 times negative 4/3, and we'll add 7 to that. Sorry, the screen keeps jumping. So we'll distribute 6 times negative 4/3 with y equals, that'll be negative 24/3. We'll reduce that in a moment, plus 7. Negative 24 divided by 3 would be negative 8, plus 7. So then y would be equal to negative 1. So we now have our x value, we have our y value. You could just box these in and say x equals y equals, or kind of a bit better, we want to get in the habit of writing these as coordinate points. So we have our x and our y, and then we'll say that that is our solution. The idea here is that you're going to be substituting, right? We're using the substitution method. So you need an equation that is isolated for one of the variables. Could be x, could be y, won't make a difference. And then you'll substitute that entire expression into the other equation, solve for a variable, back substitute to solve for the second variable. So hopefully that's a good start to this. It gives you some general understanding. Don't be afraid to make mistakes on these. Give them a try. You can always use the graphing method to kind of check your work for some accuracy. But this is a good start and a good introduction to the substitution method.